least common multiple. So this is not a new thing for people, and people must have done or calculated LCM HCF in school time, definitely at some point. So let's see what method do we take for GMAT, what method works for all the questions of GMAT, okay? And we'll stick to that method. There could be more than one methods of calculating LCM HCF, but we'll see one method and we'll stick to it because that's one method which works with all GMAT questions, okay? Let's say, let's take few numbers, 24, 44, 72, three numbers randomly. We'll see how do we calculate LCM of all the numbers. First, we need to break the numbers into prime factors. For example, 24 can be written as 8 into 3 or 6 into 4. Okay, but in 8 and 3, 8 is not prime. 6 into 4, 6, 4, both are non-prime. So, like 8 can be written as 2 cube and 3 can be written as 3 raised to power 1. So, 2 and 3 are prime numbers. That's what we want. Okay. A number is supposed to be broken down into prime factors. So 24 is 2 cube into 3 raised to power 1. 44 is 4 into 11. 4 would be 2 square, 11 raised to power 1. 72, 8 into 9. 8 is 2 cube, 9 is 3 square. So now the numbers have been broken down into prime factors. Now for LCM, we need to pick all the prime numbers available. All the numbers in three original numbers. 2 is there, 3 is there, 11 is there. Okay, 2 is there, 3 is there, 11 is there. There is no other prime number available in the three original numbers. Now we need to take their highest exponents. For example, highest exponent for 2 is 3. So 2 raised to power 3. Highest for 3 is square, 3 square. Highest for 11 is 1. And multiply them. That's your LCM. It's a simple process. Prime factorization is first step. Second, take all the primes available, 2, 3, 11, and their highest exponents, highest powers. That's how you get LCM. That's a very simple process. This is the process which works with all GMAT questions. Okay. We don't have to take any other method. This is the simplest method to say. You must have seen other methods also in school, but this is the only method that works. Okay. Now let's see HCF. So highest common factor or greatest common divisor. Okay, both are same thing. Highest, greatest, common, factor, divisor, both are same thing. So the word used could be both. Okay, highest common factor could also be used. Greatest common divisor could also be used. So let's take three numbers: 24, 72, 132. First step, again, prime factorization. Break them into prime numbers. 2 cube into 3 raised to power 1. 72 is 8 into 9. 2 cube into 3 square. 132 is 3 into 44. So 3 raised to power 1 into 44 is 4 into 11. 2 square into 11. So we have broken down into prime factors, the original numbers. Now take only the common primes. Okay, only those prime numbers which are common in all the numbers, like 2, 3, 2, 3, 2, 3. So 2 and 3 are available in all the prime numbers. 2, 3 are available in all the original numbers. Then take their lowest exponents. Example, for 2, the lowest is square. Okay, we don't have less than 2 exponent in any number. So for 3, minimum is 1. So 2 square into 3, which is 12. 12 become your HCF. So I repeat the process. First step, prime factorization. Second, just pull out all the prime numbers which are common in all three and then take the lowest exponents. That's how we calculate HCF. Let's see some questions. What is the smallest number which is exactly divisible by so and so numbers? Okay. Now you see in official GMAT questions, LCM, this word would be very rare. Or if I can say, no question will use this word LCM in any official GMAT question. So we need to figure out from the language as to whether we need to calculate LCM, HCF or something else. So we need to figure out smallest number which is exactly divisible by. Okay. So the number must be divisible by each one of them. So if I say x upon y, if I say y is a factor of x, that means x is a multiple of y. Okay. So if y is a factor, x is a multiple. So the number must be divisible by all these numbers. So all these four numbers are factors of the number that we need to calculate. Or we can say, if these numbers are factors of the number, that number will become multiple of all these numbers. Right? I repeat, if these four numbers are factors of the number that we need to calculate, so that particular number becomes multiple of these numbers. So that number will be a multiple of all these numbers. Okay? That's what we call common multiple. And the word smallest, that means least. Okay. So from the language we figure out that we need to calculate least common multiple. So the numbers are 12, 24, 56, 60. Break them into primes. 12 is 4 into 3, so 2 square into 3. 24, 2 cube into 3 raised to power 1. 56, 7 into 8. 8 is 2 cube. 60. 60 is 15 into 4, so 2 square into 3 into 5. Now, to calculate LCM, we need to take all the primes. 2 is there, 3 is there, 5 is there, 7 is there. And their highest exponents. So highest for 2 is cube. Highest for 3 is 1. Highest for 5 is 1. Highest for 7 is 1. So that is your LCM. Okay. So 8 into 5, 40. 40 into 7 into 3, 21. That number will be 840. That's your answer. Okay. If you have any confusion, just go back and watch this video again, or if you want, you can go back and watch the concept again itself. Let's take another question. Greatest number that will exactly divide 400 and 640. So the number will divide these two numbers, 400 and 640. The number will be a factor of 400 and 600. So the number will be a factor of both 400 and 640. So we are talking about common factor. Okay, and greatest, that means highest. So we are talking about HCF of these two numbers, 400, 640. Okay. See, one thing you can notice when you calculate HCF, if we divide both sides by 10, what do we get? 40 and 64. Okay. So take one second. Okay, let me write it again. So we're talking about 400 and 640 common factor or highest common factor, okay, greatest number of 400 and 640. You can always take 10 out. 10 would divide both of them. So after dividing by 10, we're left with 640 and 64. So that'll make numbers a little smaller. Okay. So for example, if we had 400 and 600, so we would have taken 100 out. So 4 and 6 are remaining. So 4 is 2 square, 6 is 2 into 3. So if we want to find HCF of 4 and 6, so that will be 2. 2 is the only common one, and the lowest power is 2. Now 2 is common factor for 4 and 6, but we are talking about 400 and 600. So we took 100 out, 2 into 100. Okay, I repeat, 400 and 600. If there is something that we can already take out, some number, let's say 100, that will make the numbers really small. And then we can find HCF of those smallest new numbers. So whatever the HCF is, we can multiply it by 100. Similarly, we took 10 out. So we'll calculate 40 and 64. So 40 is 4 into 10 or 8 into 5, 2 cube into 5. 64 is 8 square, so 2 raised to power 6. So the only common prime number is 2 and the least power is 3. Okay. So 8 is common factor, highest common factor for 40 and 64. We already took 10 out, so multiplied by 10, so that becomes 80. That's your answer. Next question. Okay, let's see this question. So read the question carefully, pause the video, read the question carefully, what are we talking about, and then proceed to answer this question. Try to answer it yourself first, then watch the explanation. So there is a concept which is, if we have just two numbers, okay, if we have just two numbers, so the product of the two numbers is equal to LCM multiplied by HCF. Okay, if we have just two numbers, don't try this concept with more than two numbers. So if you have only two numbers, the product of LCM into HCF is equal to product of the two numbers. So it says the product of the two positive numbers is 144. So let's say x into y is equal to 144. Okay, so which of the following could be the LCM and HCF of the two numbers? So LCM into HCF should also be 144 because that is product of the numbers. Okay, now let's see. So here the product would be 144. 18 into 8, again 144, 16 into 9, 144. So in all the three options, the product comes out to be 144. So it's very tempting at this point that you mark all the three could be LCM and HCF. But we know we can have only one particular value of LCM and one particular value of HCF for any given set of numbers. Now, how do we eliminate wrong options here? On what basis, on what logic we eliminate the numbers? Now, if we see, LCM has got all the primes and their highest exponents. Okay, HCF has got only common ones. Okay, that means whatever is there in HCF should be there in LCM also. Okay, or simply saying HCF has got only some part of LCM. What I'm saying is LCM has got everything, all the prime numbers. HCF has only some of them. Okay, so HCF has got some part of the LCM always. So HCF should always divide LCM. Okay, because HCF is just some part of LCM. For example, let's say LCM is 2 cube into 3 square into 5. Let's say, I'm just taking any example. So HCF would be like some part of it, let's say 2 square into 3. I'm just taking some example. HCF will be, whatever is there in HCF will definitely be there in LCM. So HCF will always divide LCM. Okay, for any set of numbers for that matter. So HCF should always be a factor of LCM. So if we see 24, 6, does HCF divide LCM? Yes. So first is possible. Second, does 8 divide 18? No. Does 9 divide 16? No. So from just one logic, which is product of the numbers is equal to LCM into HCF, all of them satisfy it. Okay, but if we go by the nature of LCM and HCF, what actually they are, HCF should always divide LCM, so only one option satisfies it. So that's your answer A. Okay, next is units digit. So when we say units digit, we are talking about units digit of an exponent. Okay, for example, 12 raised to power 85 will be the units digit of this number. Okay, if we expand it, if we finally put it into a number, what will be the units digit? Let's see the concept behind it, because 12 raised to power 85, definitely we are not going to solve it. So let's take any number 2. So 2 raised to power 1 is 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, 2 raised to power 6, 64, 2 raised to power 7, 128, 2 raised to power 8 will be 256. Now if you see, the last digits are 2486, 2486. Now this sequence of last digits will keep repeating. Okay, 2486, 2486, 2486. This sequence of 4 digits will keep repeating. As we take more and more powers of 2, more and more exponents of 2, this sequence keeps repeating itself. Now, for example, I need to find 2 raised to power 7 will be the last digit, or the units place digit. Okay, so 7, the exponent. Okay, take the exponent, the power, divided by 4. Why 4? Because it's a sequence of 4 digits. It's a complete sequence of 4. Okay, every number repeats after 4. So 5 after 1, 6 after 2, 7 after 3, 8 after 6, 8 after 4. Okay, so every number repeats at every interval of 4. So take the exponent, divide it by 4, and just see what is the remainder. Okay, so the remainder here is gonna be 3. So we just check 2 raised to power 3. 8 is the last digit. Okay, 8 is the last units place digit of 2 raised to power 7. Okay, we don't have to actually calculate 2 raised to power 7. Take the exponent divided by 4, because 4 is it. I mean, every number repeats after 4. Just see what is the remainder. Remainder is 3. Just check for 2 raised to power 3. Okay, if you are getting confused at any point, just repeat this video. I mean, rewind and repeat 2-3 times, you'll get a hang of the things. Okay, so now let's say 3 raised to power 89. We need to find last digit of this. So 89, the exponent, divided by 4. Okay, what is the remainder? Remainder is 1. So we just check for 3 raised to power 1. Last digit is going to be 3. Okay, now let's say the number is 3 raised to power 80. Take the exponent 80 divided by 4. Remainder is 0. So what do we do if the remainder is 0? We simply check for 3 raised to power 4. Remainder 0 means the exponent is a multiple of 4. For example, 3 raised to power 4, 3 raised to power 8, 3 raised to power 48. All those which are multiple of 4, we just check 3 raised to power 4. That's going to be 1. Okay. Now, let's say we took one example in the previous slide, that was 12 raised to power 85. So what do we do in this case? I mean, 12 raised to power 85 or 452 raised to power 85, let's say. These two numbers don't matter. What matters is just the last digit here also. What it means is we just need to check for 2 raised to power 85. Okay, 12 raised to power 85, we just need to check for 2 raised to power 85. 452 raised to power 85, we just need to check for 2 raised to power 85. So 85 divided by 4, remainder is going to be 1. So 2 raised to power 1, we just need to do that. Okay, so that's how we find last digit of any given exponent. So that's it in this video. We have covered LCM, HCF and units digit. Very important from a number properties perspective. Okay, thank you.